Okay, so what we're covering today is surface area of prisms and cylinders. We're going to start with the prisms first. It is helpful while you're doing these notes to have a highlighter in addition, just so you can highlight the pieces of the prism that you need. And it'll make more sense in just a second. So I've got my highlighter. If I look at the first problem, I've got a rectangle down here as my base. I'm going to highlight that rectangle because that is the face or the base of my prism. Now before we go too deep, we have to change some formulas because there are some typos. This, instead of saying 2b, should say pH. So if you read through below the formulas, big B stands for the area of base, P stands for the perimeter of the base, and H stands for the height of the 3D shape. That's the same thing as between the two shapes, let's call them, or between the two bases. So if you look at number 1, we identified it was a rectangle. In order to find the area of the base, you have to remember the formula to find the area of a rectangle. That would be length times width. I'm going to identify my length, that's 13. My width is 7. In order to get my answer, I'm going to say length, or 13, times width, or 7. When I put that in my calculator, it leaves me with 91. I also have to find my perimeter and my height, so I have nothing left to find once it's time to start plugging stuff into equations. My perimeter is just adding all four sides together. So perimeter is 13 plus 7 plus 13 plus 7. That gives me 40. And the last thing to identify is height. Height is always between my two faces, or my two shapes. In this case, it's the rectangle. So my height is this one right here, the 9. Now, in order to move on, all I'm going to do is plug stuff into my formulas. Above the LSA, or the lateral surface area, I wrote the piece that I need, perimeter times height. Perimeter, we've said, was 40. Height, we said, was 9. I'm going to plug that in my calculator, and it's going to give me 360. Don't forget your units. Okay, then next, I'm going to take this pH part, and I'm going to use it to find part of my surface area. If you look at the formula, I've got 2 times the base. That's what we found up here. Plus the thing we just found, perimeter times height. So that's going to say 2 times 91 plus what we just found of 360. When you type that in your calculator, it should give you 542 feet squared. Now, I have to look at my next one. My next figure is a triangular prism. And here is the piece that I'm looking at. Your triangle can be on top or bottom. In this case, I'm going to use the one on the top because it's just a little bit easier to work with. The formula to find the area of the base, or of a triangle, is 1/2 base times height. I'm going to use 0.5 times 0.5 in place of 1/2. Now if you look at this triangle that I highlighted, here's my right angle. The bottom triangle is going to be the same as the top triangle, so if there's a right angle here, there's a right angle there. That means this piece right here, 9, is my base, and 12 is my height. When I type all of that in the calculator, it gives me 54. Now, I have the area of the base, so I'm going to move to finding the perimeter. perimeter for a triangle has 3 sides, so I should be adding 3 numbers together. The base, the height, and then I need the hypotenuse. It is printed down here at the bottom for us. So that leaves me with a perimeter of 36. Then I need the piece that is the connector between my 2 triangles. That would be 16. That is my height. Now I can start plugging stuff into my formula. Perimeter times height is 36 times 16. That leaves me with 576 meters squared. Then, to find the total surface area, 2 times the base, plus the perimeter times the height. So 2 times 54, plus 576. That leaves me with 684 meters squared. So really the most intensive part of this is finding the base and the perimeter. Everything else I'm just plugging into formulas. So let's look at number 3. Number 3, my shape is not always going to be on the top or the bottom. Because if you notice, the top of this is a square, looks like a square. The bottom of this looks like a rectangle. Those two things are not the same. When you're finding the shape, you want the piece that is the same top or bottom or front to back. So here is my shape. This shape is a trapezoid. So that means I'm going to use the formula to find the area of a trapezoid. That's half times height times base 1 plus base 2. My height is always with my right angle. That's 12. And then my bases, I've got 23 on the bottom. And then I need to figure out this top base. Well, luckily on the opposite side of it, it's 18, and I know those 2 sides have to be the same because they're parallel. If I were to plug all of this into my calculator, that gives me 246. Now I've also got to find my perimeter. Remember, perimeter, you are always adding the amount of sides the shape has, and a trapezoid has 4 sides, so I should have 4 numbers. I've got my height, which was 12, plus my first base, plus my second base, and I need this diagonal piece. Kind of going along with the same rule from the 18 being the same on the back and on the front. This 20 is going to be the same here and here because those 2 pieces are the same. When I add all 4 of those numbers together, I get 73. Now I'm just going to start plugging stuff in to find my lateral surface area, or LSA. That is perimeter times height. My perimeter is 73. And when it says height, it does not mean height of the trapezoid, it means height of the prism. So that means I am looking for the connecting piece between the front face and the back face. That would be this 15. That's going to be my height. So I'm going to type 73 times 15 into my calculator. And that leaves me 1,095 feet squared. Now I'm going to do the same thing for the surface area. Plug in everything I've got. I need 2 times the base, so 2 times 246, plus what I just found for pH, 1095. When I type that in my calculator, that leaves me with 1587, or 1,587 feet squared. Now moving to the next one, it is quite similar to the one above this, but there is one small change. So here is my trapezoid. Remember, it can be front face and back face, top face, bottom face, depending on where the shape is. I know there's a trapezoid, so same formula as before, 0.5 times height times your bases added together. My height here, it shows me the height of this trapezoid is 12.4. My first base is 10. And this time it was nice enough to give me that these 2 pieces are parallel, so that means my other base is 18. When I type that in the calculator, I'm left with 173.6. Now I've got to find my perimeter. Remember, perimeter means all four sides. Because it's all four sides, I have to use the four sides of this. 10, 18, and then I need these two sides here. If you look really closely, there are tick marks there. Those tick marks are also here with this 13, so that means that I have two 13 sides. You'll notice we did not use the height on this because the height for this trapezoid, unlike the one up here, this one was a side length. This one is just on the inside. Because it is on the inside, we do not use it. Perimeter is just the outside. Now, I multiply those two things. I add all those things together and I get 54. My brain is all jumbled. Now to find my lateral surface area, remember it's perimeter times height. That means 54 is my perimeter times my height. The piece that is connecting my two trapezoids is this 9 up here. So 54 times 9. 54 times 9 gives me 486. Now I'm going to use that to plug into my formula for surface area. Surface area is 2 times the base, so that's 2 times 173.6 plus that piece I just found, perimeter times height, 486. When I add those things together, I should get 833.2 millimeters squared. Okay, for my last one, I've got a triangle again. Finding the area of that face gives me 0.5 base times height. Remember, the base is below the right angle. So that's 8. Height is going up from the right angle. That's 15. If I type that in my calculator, that should give me 60. Now I've got to find the perimeter. Nowhere listed is the hypotenuse of this right triangle. That means I've got to figure out the hypotenuse of this right triangle. That is the square root of 15 squared plus 8 squared. Once I find that, that gives me this distance. And then I can find my perimeter. If I were to type that in my calculator, that would give me 17. Now to find the perimeter, I would add those 3 together, which gives me 40. My height is the piece that connects these two, that's 21. So I've got my perimeter times my height, or 40 times 21. That gives me 840 inches squared. Then to find my surface area, I'm going to do the same thing as I've done in all the rest of them. I'm going to take 2 times the base area plus the piece I just found. That should give me 960 inches squared. Once you've got all this copied, flip your page over. Okay, so now we're going to look at cylinders. Kind of like on the page before this, there is a typo. So cross out this formula, and you're going to rewrite it as 2 pi radius times height. Now we're going to move on towards identifying stuff. You'll notice that in these, there's just really 2 things we're looking for. The radius and the height. The height, if this was like a can of Sprite or a soup can, would be where you would hold the can itself. It's on the smooth looking part of the cylinder. So the height right here is 26. The other thing that I need is the radius. Remember, we did radius last unit in circles, very similar to this unit. The radius here in number 6 is 11. So now that I've got those, I just need to put them in the formula where they belong. For me to find LSA, that is 2 pi radius times height. That means it's 2 pi times 11 times 26. If I type that in my calculator, that leaves me with, rounded to the nearest appropriate rounding, 1,000 797 yards squared. Now for the surface area itself, I'm going to do kind of similar to how we did in Prisms. We're going to combine our lateral surface area and a new little chunk of an equation for our regular surface area. So for my lateral surface area, I've got 1797 plus, if we look over here at the formula, 2 pi r squared. We know radius is 11. So when I type that in my calculator, this whole thing, I get 2557.3 yards squared. Now for number 7. Number 7 is very similar to number 6, except there is one thing that is different. I have to find the radius. In this cylinder, it gives me the whole length, which is the diameter. That means I have to take this radius, or 15, and divide it in half. My height, or where the smooth part is 9. Now I'm just going to plug everything in. My lateral surface area is 2 times pi. Forgot to simplify that. 15 divided by 2 is 7.5. So 2 times pi times 7.5 times 9. When I type that in my calculator, I am left with 424.1 meters squared. Then to find my surface area, same steps as in the one before this, 424.1 plus 2 pi r squared, so 2 pi 7.5 squared. That leaves me with 777.5 meters squared. Now for my very last problem, it's a word problem or a real-world problem. That is what application means. So if I read through it, it says the surface area of the soup can, this one here, is 51.84. If the diameter of the can is 3 inches, find the height of the can. Well, if we look back at the formulas we did above this in 6 and 7, nowhere did we have diameter. So I want radius. To find that, I divide it in half. That gives me 1.5. Now I'm going to use the surface area formula. That's SA is equal to 2 pi r squared plus 2 pi r h. Now I have SA and I have r, so I'm going to plug those in where they belong. 51.84 is equal to 2 pi 1.5 squared plus 2 pi 1.5 times height. And you'll notice I put height in the parentheses. Everything before that set of parentheses, so from this point all the way to that point, those are all just constants. Because they are all just constants, I'm going to type them in the calculator exactly how it looks. 2 pi 1.5 squared plus 2 pi 1.5. That will give me a constant. When I type that in, that gives me 23.6, and then I'm just left with the h. Now to get h by itself, I'm going to divide both sides by 23.6. That gives me an h of 2.2 inches. If you've got any questions, please reach out to your teacher.